Ne, ale jako jo, 24 meetupů.
Jako vstupní kontrolu.
Ne, vůbec.
Se ještě
Vůbec. Hele,
kolektivní dodávky.
občas, jako jo, se dělá registrace, ale to je vidět prostě na recepci.
Jo, jasně.
Tady ne, to je jako prostě, to nás se nezajímá upřímně.
Jo.
Jako takhle jsme rádi, jako samozřejmě ty lidi přijdou a děláme to komunitně. Jo? Jde o tu komunitu, to je prostě to, o co nám jde. Nejsme nějaký propadený KubeCon, který jako, co si budeme, je prostě komerční.
Taky nebyl.
Já jo, už se vlastně pojedu.
Jo, oni z toho ty kurvy mají docela velký prachy, my z toho
Jako,
máme hovno.
já to chápu, jako
Ne,
prostě,
nemáme z toho
ale jako by z toho
žádný
reálně
čas.
nic nemáme. Jo? Prostě jako děláme to ve volném čase, nic z toho nemáme, ale dobrý pocit, jako mě ta komunita
Tak
baví,
já
že
to
jo.
asi přepnu na
Jo,
stopku, ne?
klidně se připoj.
Tak děkuju každopádně.
Jasný, hele, tam je pivo, záchody nevím, kde jsou, to Zdeněk řekne.
V budově.
Když tak ten notebook si dej sem, Zdenku.
Dobře.
Data máš teda.
Pojďte si to moc zažil. Čus. Tak co, jaká byla cesta?
Jo, je to...
Co by to udělat líp? Nebo to nejde udělat líp? Jedeš?
Aha, OK, no, tak... Tak...
Ještě lepší.
Taková malá, možná jsi slyšel. Ale 15 lidí čekají. Hele, Zdenko,
To stačilo.
Určitě.
já si báka nechám tady, co ty na to? Zdenku,
Nech si ho kde chceš.
dík. Jsem rád, že mi to dovolíš.
Jsi to zakazoval, ne?
Přesně. Hele, vypadá to, že stream jede, já si tam sednu, pustím si zvuk, takže to je mikrofon. Hele, mikrofon, ty, mikrofon, speaker. Já vám za vámi budu běhat, prostě vypínat.
Já si mám normální mikrák, no.
Jo, tak já to vlastně.
Počkej, já vypínání si pamatuju, tady zmáčknu.
Jo.
Svítí zeleně, co ten debil.
To není vidět, zmačí to. Jo, no to není ani vidět, to je retardovaný. Protože to je barvička jako který.
1, 2. 1, 2. Já jsem dvojka, že jo?
Ale musí se pohlídat, protože o ta baterka chcípne, on jsem ho dobíjel, on není dobitý, vidíš to?
Chci ho nabít, mám ještě dost času?
Máme 10 minut, máš Cčko?
Mám? Nabíječko, to
No, já nemám žádný volný USBčko
mám,
právě.
no, já mám normálně...
Počkej, já nemůžu vzít notebookovou.
Já mám normálně dozasky.
Dobíjím, vydrž. Dobrý, dobíjím. Jo.
To mám nějakou dozasky, kdyby si chtěl.
Tak jo, jestli tam je ještě zásuvka, tak to bude lepší.
Jakože, no není to Cčko, takže to bude pomalejší, jestli máš C.
No, mám no, takže si to nech. Já mám notebookovou, že jo. Čau. Doufám, že se vám to líbí. Dneska to je hodně punkový. Lítáte nějaký hmyzou. Já chci, aby se mi nevypnul display.
A radši dám notebook na nabíječku, aby se to pak nevyplo.
Power, maximum charge, performance. Power saving, když jsme to předělali. Automatic power saving. Dobrý.
To je Mac?
No.
Ty vole, přesně tenhle mám doma, ty vole.
Co? Tenhle Mac?
Ten buben.
Jo, já mám černý.
Fakt, a tam není volná díra. Tak to přežiju.
A vydržíš to?
Jo, je napájení. Já jsem spíš myslel, aby se to už nevyplo jako do power save modu, víš?
Myslím si, že tohle je nejvíc punkový meetup, co jsme na tím dělali. Kromě toho prvního. Nebudu lhát, tak přemýšlím nad tím nechem. Po té baterce. Čau.
Venku. Takový alternativní prostor. Nebo kdyby pršel, máme i stanu.
Máme stromy. Ty stačí.
A takhle, bylo to napsané v tom eventu, že jste venku. Ale to nikdo nečte, já vím, takže v pohodě.
A to příští bude hlavně venku.
A co mám udělat?
to už asi nepovím.
Michal to splní.
Ale já ti nevím, těch pár metrů to chtěl se jinak.
Ty vole, volí má celé 2 měsíce. Ještě psal, jestli
Nebo severní. Krmička by byla. No pro mě, já bych si rád dal, ale já ne. To není pro mě, já nevím, pro koho to bylo. Pavel točí pivo a už říká komu? Čau. Já jsem tak rád, že teďka budeme mít na měsíc klid, měsíc a půl.
Tady máš to pivo, nevím pro koho je.
Káme.
No to je mi jasný, jo, že je spousta lidí jede na DevConf. Já jsem tam byl několikrát a řekl jsem, že poslední to bylo tak špatný, že tam jako nejde. Ale... Jak druhý to je tenhle, já vím, že jsem poslal od domu lidem deníčku a přišel jsem tomu, takže...
Já jsem, jak tam byly ty zádry, ale nebyl jsem jo, bylo to jak to nefungovalo, takže já jsem hele, jak to bylo, že jsem a
potřebujeme maximální kampus.
No, vlastně jsme tam přišli ještě.
Jako to jídlo tam je docela dobré. Že si vzít jídlo, jak je takhle za rohem. No, vem. Jak to něco, ať to je mít na té hladově žíně.
4 minuty, já vás poslal neviděli, pane organizátor.
Jakože můžeme to odjít někam, ať to vypadá líp, to jako jo.
Chceš hezký fotky? Já fakt nemám problém. Potřeba mi to lítat.
Ty vole, on přišel, a ještě na druhou stranu dělá, že nás nezná.
Ne, vaši lidi se neregistrují. Já jsem s tím počítal. No, počkej, já prostě jsem psal 4, já jsem počítal, že tam mezi nějaký vaši lidi. Ale to měl být výstek, já jsem prostě ani to není kašlo. Ale to je dělá.
Ale to se pak říká,
Ale místa je dost, takže...
a pak
Budu se dělat.
Je.
Dobrou chuť, to právě vy máte. Nazdar,
Čau.
jste si říkali, že nás nesnášíte.
Děkuju.
Registrace, ale prosím tě.
Já jsem se registroval online, jakože nějaký check-in nebo něco. Není.
Zdeňku, už budeš muset.
To je komunikace, jakože...
Vy byste měli mít ceduli no check-in required.
Někdy to je potřeba. Záleží na hostiteli.
My ho děláme, protože ho vyžaduje ten hostitel.
No tak právě, když není potřeba, tak mít ceduli.
Ty vole, možná jo, no. A nebo to prostě udělat
A my
mandatory.
to většinou máme, když jsme v budově,
Hele,
tam je člověk a máme jako
máš
apku, děláme
40
kód,
Nemáš obraz, máš 40 vteřin a nemáš obraz.
Já vím.
To je dobrý, je to víš.
To je to, jak jsem
Děkuju.
říkal, ten power save moty, vole, ne? Tak jako...
Dobrý, obraz tam je. Hele, tady máš mikrák. Prostě začni tak nějak.
Jo.
Uděláme to punkový, bude tam pořád to samý. No.
Já jsem rád, že žiju, takže jako... Myslím, že můj největší úspěch je, že jsem tady dneska, takže... Bude i záznam.
Doufám, že bude příště vyhraná tiskárna.
Jako musíte se víc snažit, jo, příště.
Já jsem si říkal, ty vole, je to jeden z nich, ty vole. Nebudu chuť.
To je jen tak ze srandy, ty tři notebooky tam jako.
Flex.
Jako je to velmi kreativní, ale to...
Tak je to punkový event, ne? Tak...
Kamera.
je z mou boku.
Z jakýho?
Z toho černýho. A nejí to ten tvůj, prosím tě. Můžeš začít.
No to vím, že to není můj, vole.
Už začni.
A ještě mám minutu.
Ne, už je 18.
Podle tohle jako máš 6 minuty po...
Já si to taky myslím. A tolik baterky nemá?
Co mám si počítat?
Mám hodinky.
Jo, to pak nebude.
Ty vole, tak ty Garmin asi nefungují, já nevím, no. Je dobrý, tak víš.
To by vadí pro Meetup.
Čekám, až si sedne. Poslední a začnu. Já se ještě pojďme jenom, jestli tam není ještě někdo jenom. Tak jsou tam nějaký 4 lidi, tak na začátek nikoho nezajímá. Takže jem? Tak již tak, jo? Tak, hi everyone, I'd like to welcome you on the next Cloud Native Prague Meetup. Today we will be speaking about, Kubernetes, but mainly about how to run the Kubernetes. I mean, the hardware part, the basis ones. So, if you wanted to help us, like via involvement.cloudnativeprague.cz, you can reach us, just Google form. So, we are not alone. I mean, the community, there are more of them, like the Kubernetes community days, Golang meetups, Prague DevOps meetup, and stuff like that. So, I'd like to, show something. Tomorrow there will be a meetup in Pure Storage for the Golang. So if you are interested in, I think there's still some free spaces. I'm not sure. Probably yes. There's also one more event. It's in 3 weeks I think 3 weeks. So it will be Prague DevOps days. So you in Sky. So you can also join it. So. Today I'd like to thank CDN77 because they provided this space, and also the catering, which is in right or yeah, on my left. So so please make some applause for them because we can't do that this event without them. So, and also there are some people from the company, so you can speak with them. Today we have 2 talks, as usual. So first will be by Michal. He's from the CDN77, and he will be speaking about Talos. If you were on our last meetup, we also spoke about the Talos. So I think that this will be more, deep dive. I hope so. And the second talk will be by Emrat, and he will be speaking about secure boot and TPM. One thing is run the Kubernetes, but maybe you should also make your machines more secure for running it. So, if you have some questions, so please use Slido, so you can scan the code or just write the CMP24. Yeah, of course, you can have some questions here, but we prefer the Slido for the voting. So, the QR code for the Slido will be there all the time. I mean, on the right corner. So you can scan it when you want. And that's it from my side. So I'd like to welcome on the stage the first speaker, Michal. So stage is yours.
Tak se máš mikrofon. Tak.
Tady máš.
Tak, HDMIčko je tady. Tady máme HDMIčko. Jo, on to za něj zahodí s tím adaptérem. A tam máš ten pantuge.
Já v rychlosti klipr, nevím, jestli dopředu, dozadu.
Jo, já jsem to zkoušel.
A tohle, když podržíš, tak ti ukazují, na ti to zase ukáží to kolečko.
A jak mám 2 monitory, jak to moc nefunguje, takže jakoby...
No, musíš přejet, je to nahoru, jo. A je to Mac Optimized.
Dobře.
Jo, to je dobrý. To stres, víš jak.
Já nejsem ve stresu.
Before we start,
jo, jsi tam. To tam.
There's some food.
Kdyby náhodou, tak tady je monitor, můžeš si tak mrknout sem.
Jo, já mám ten druhý poslaný sem, to je jedno.
Jasně. Jo, jasně.
I can do magic.
OK, já jdu počít.
There's brandy t-shirts also. Can you grab 77 t-shirts?
Where's Hanka? Do you have 77 t-shirts?
You can?
Okay, 77 t-shirts, maybe yes. 70. 77 CDN 77 t-shirts will surely be there. Okay, hi. My name is Michael. I'm from CDN 77 and I would like to tell you something about Talos Linux. What is it and why should you use it? Just a little bit of context. CDN 77 operates over 35,000 servers over 100 locations. Majority is not Kubernetes currently. And we have some Talos Kubernetes clusters. Currently we are talking about 3500 AMD Epic Genoa cores with more than 6 terabytes of RAM and terabits per second of network throughput per cluster. And funnily enough, I don't do Kubernetes at CDN 77. I do something completely different. But I personally liked I have personal side projects on which I also use Talos. And we independently, in my personal time and my colleagues in company, both agreed that Talos Linux is one of the great things how to run Kubernetes. This is not to brag about scale. This is more for context that we use Talos from small personal single node projects up to pretty large clusters, and we have mostly great things to say about it in all of those contexts. But let's start in the beginning. Kubernetes. I think it's great. Everyone probably here hopefully loves it or or think it's great. It solves a lot of problems like scaling, networking, clustering. You all know that. My favorite part is that it's mostly declarative and gives us this immutable workload environments. So okay, sorry. No down. But I don't want to talk about Kubernetes specifically. Let's agree we want Kubernetes. Okay, so if you heard about Kubernetes the first time or you just Google around, the first thing you will find is that to get Kubernetes, you should get one of these managed offerings from the big clouds, or today even smaller clouds. But when I heard about Kubernetes, one of the promises is it's lock-in free. I don't have to be locked into one of the big clouds, but this seems I have to be locked in one of those big clouds. Can I get something more lock-in free? Or I know this is kind of heresy saying this on cloud native meetup, but something cloud free? Or at least being something that can be brought out of the cloud when needed, because cloud has kind of not many problems, but there are problems with cloud. I would like some way to run Kubernetes outside of those lock-ins. So okay, let's get a generic VM or some bare metal server and try to install Kubernetes. When you open the documentation on official Kubernetes documentation, you will find this page about kubeadm, which is supposedly the easy way to set up Kubernetes. This is the easy way. And when you start reading the page, you will find a lot of things you have to do to set up it. It even skips about you have to have a Linux, and then you have to check and install a lot of things, run a lot of commands. And this is not what I was promised from Kubernetes. I want something that's a kettle, not a pet. I want something that's in Git, that's versionable, that's infrastructure as a code. This is not it. And okay, when you search around, you will find other alternatives like kubespray, which is most like Ansible kubeadm, and also K3s, Rancher, K0s. It's all of kind of the same. It's still manage your Linux hosts. It's more opinionated. I think it's more wrong. This is not what I want. I would like something that's close to manage Kubernetes, but outside of the big clouds, outside of the big management. Why can't I do that? I want something that has safe and painless upgrades, because my biggest gripe with all those systems over the years I run them was that I always do something a little bit non-standard and the upgrades completely break down. I have to do a lot of manual steps to get out of it. So I want something immutable, declarative, something where all this can be done safely. And I don't want to use Ansible. Don't get me wrong. Ansible has a lot of. No, it has lots of. I know how to run, how to do Ansible and manage Linux servers. I just don't wanna, after all these years. Couldn't there be a Kubernetes-oriented Linux distribution, a full distribution that does all this stuff? Just like I want to install it and run Kubernetes and don't worry about the underlying Linux, like a managed Kubernetes. Well, enter Talos Linux. It's a Linux distribution and Kubernetes distribution. It's a Linux distribution specifically for Kubernetes. It's very minimal and the root file system is immutable. It's not based on some Ubuntu and Debian. It's Linux kernel and just a couple of binaries. It doesn't even have SSH. You cannot log into the server. It just provides a simple API over which you can configure the server and don't touch it. And it can run in all bare metal and VMs and cloud and all matter of heterogeneous environments. So let's try to install it. How do we do it if we don't have SSH? First, we will need to generate a Talos config. This is a little bit weird, but we will go through it. The first step is generate a Talos config and then set up a machine and apply the config to it. Let's walk through all the steps. First, you will need to get Talos control, Talos CTL, which is another binary. I know everyone has a lot of binaries on their computers. This is another one, but it greatly simplifies the operations of the cluster. So get a binary. Then you have to generate secrets. You don't have to worry much about this file. It just generates the seeds and generates all the required secrets for the whole cluster, and this is the only file you need to keep secure. And don't present it anywhere. Yeah. I don't recommend doing this. Then you take the secrets file. I don't know how it's visible. It's visible. You just need to provide cluster name and Kubernetes API endpoint, and you can generate config. This is all you need for a basic happy path config. It will generate a couple of files for you. That is Talos config and Workday control plane machine configs. Talos config is equivalent to kube config. It's just a config with basic auth for the Talos API. You don't have to worry about this file mostly at all. And then you have the machine config. This is one fairly large YAML files. Who doesn't like large YAML files? But as you know, by default, it's mostly commented out. It has a lot of examples, and you don't have to worry about it. Not at the first step. It has fairly sane defaults. You can start just using that. It mostly works. Yeah, but let's move on. You have this machine config. You get an ISO. You get that from release pages or from download page, and you boot it like you would any other ISO for installation. This will boot a minimal system into DRM and just expose API. It won't do anything with the machine yet. Then you need to take your config and apply it to this in RAM booted minimal system. This will take the system, install it on the drive, do all the things that are set in the machine config that should be done, which by default is for control plane, run all control plane static pods, run kubelet. For worker, it's just run kubelet and join the Kubernetes cluster. This will join the Kubernetes cluster and do all this other stuff for you. You may notice that for the first apply config, I am passing the insecure flag because as we booted the machine, it doesn't know anything. It doesn't have any certificates. It doesn't have any auth. So please don't do this in public internet on public IPs. Don't ask. You just have to believe that those IPs are the correct IPs of the machines you booted, and you send the config there. Then you will need to have set up Talos config. As I said, it's the same thing as kube config. You just need to tell Talos CTL where to find it. It has some default paths, but I try to do it explicitly here. And then you call on Bootstrap on one node. The Bootstrap is what actually setups Kubernetes. You call it once per cluster, and then you can start using Kubernetes. I have screen recording about how this can work. I don't know how visible will it be. I didn't want to do a live demo. Live demo got not to be tempted. And I know it's a little bit fast. I think we can, after the presentation, sit together and go through the steps in more detail if you are interested. But I now called Bootstrap, and I called Talos dashboard. It has this inbuilt terminal-based UI dashboard that shows you the status of the nodes. And currently, the Kubernetes is bootstrapping. It was just one comment, and now you wait. The Kubernetes components, which are visible here, will one by one start up and get healthy. Then the whole node will be proposed as ready, and we can start using Kubernetes. I will scrub a little bit. All the components are healthy. Now we need to wait until the node is ready. We have ready the control plane node, and we can start using Kubernetes. Okay, one more step. We need to get a kube config from Talos CTL. Talos CTL will derivate this from the machine config, the secrets. It can generate the basic admin kube config for you. Then that's on the happy path everything. You can fairly easily, with same defaults, get a connected Kubernetes cluster with basic services, and you can start using Kubernetes. Don't worry about the underlying system. Okay, but what if you need to worry about the underlying system? What if you need to change something on this immutable system? Oh, all was great till now, and now I have immutable system, and I want to, let's say, add an NVIDIA drivers, because everybody needs AI now and needs NVIDIA drivers. How do you customize this immutable image? You don't have to worry. All these customization can be done on a running cluster. They are just a little bit weird, because you cannot just SSH into the nodes and call apt-get NVIDIA and all this stuff. You have to do it the Talos way. And the Talos way is to use system extensions, which are like root file system overlays, over which you can add to anything to the root file system or customize the kernel. There's a public repository of pre-built ready-to-be used extensions, where the most common drivers like NVIDIA and some VM guest agents, or even different container runtimes are available, or you can look into this repository and create your own. One thing I skipped over a little bit are images. We just got an ISO from somewhere and installed it. But Talos does this a little bit specific thing, that it has two kinds of images: initial boot image and installer image. Initial boot image is the ISO we booted into RAM. It doesn't do much. It just exposes API and is there only to expose API and write to disk. You usually don't have to customize it. The only requirements for it is working networking, which can be challenging, and working disks, just so it can over the network set up the disks. Not only can it expose API, there's also many ways, like something like cloud init, or providing the machine config on drive, where you can auto provision the image, and it can install and join the cluster completely automatically, just by providing some side channel the machine config we generated earlier. And then you have installer images. This is the image that actually runs the system and is copied or unwrapped to the disk. Those are OCI image formats stored on OCI image registries, and they are downloaded by default. They are downloaded during the initial apply config step onto the drive, and those may need to be changed if you need the NVIDIA drivers for the during the runtime, or anything specific during the runtimes. This is the image you most probably want to change. changing and building images is always kind of painful with all Linux distributions. Talos has answer for doing the basic stuff easily. They have so-called image factory. That's a web service. You can run your own, or there is a default hosted factory Talos dev service that can customize the basic customizations from the public extensions for you. Let's do a quick demo. I don't know how much. Is it visible? Let's say we have bare metal machine, because that's what we do. Let's pick Talos Linux version. We are running on AMD64, and we need the systems extension I was talking about. So let's say we want to install NVIDIA drivers, and I can't NVIDIA. Okay, I want NVIDIA Container Toolkit, LTS version, and kernel mode, the non-free one. There's quite an amount of pre-built extensions. That's the one from the GitHub repo I was mentioning earlier. If you want to have custom system extension, you cannot use the pre-hosted factory.talos dev. You will have to go to the more complicated routes of building it yourself locally. But if you want the basic drivers, we have them. We picked NVIDIA, and we can go next. We can also specify custom kernel commands. These are only for the initial boot image and are helpful if you want to have a static IP config, or you want to provide a machine config over some HTTP. They have a lot of custom kernel commands for the provisioning. After that, you will get just an ISO link or OCI image name. This generates both the initial boot image, same as installer image. You can use the same image for both, or you can customize to have some basic small initial boot image that just has drivers you need during the initial boot, and then have larger images like for your workers with, let's say, the NVIDIAs. But let's get back to our cluster. We have running cluster, and we want to add this new image to our already existing cluster. We will take this OCI image name, and we will call Talos control upgrade. This is used both for upgrading Talos versions as well as any changes to the installer image. It is mostly automatic. It will automatically cordon drain and shut down your node, and it also has implemented automatic rollback. It will actually create a new partition, dump the new image there, tries to boot into it. If it successfully boots into it, it will permanently change the boot order. If it fails the boot, it will reboot and boot into the old partition. So it's mostly safe. Use on your discretion. The thing we are doing here, which is changing, just adding NVIDIA drivers, this would be called a same version upgrade, because we are not actually upgrading Talos, we are just changing the image. Again, I have screen recording of the update. It takes several minutes. This is very sped up. I just wanted to demonstrate that you call one command, it does everything for you most of the time. Everything I say today has very much asterisk. This symbol.
Don't worry about it.
If you are upgrading Talos this way, read the upgrade notes.
Mostly.
No, read the upgrade notes.
What broke?
Nothing broke. Everything passed. We have installed the system. This is demonstrating on a clean cluster. Of course, if you have some service that takes a long time to drain the nodes, this will take a long time. It requires a node restart. The root file system is immutable. This is the price you pay. If you want to customize something, you have to do a restart. But in Kubernetes cluster, it should be fairly easy. You just cordon drain the node and restart it. Okay, we upgraded Talos. What about upgrading Kubernetes itself? That's by default also fairly easy. That's automatic run across all of your nodes in the cluster, and it's non-disruptive to cluster workloads. You can do it on a running cluster without any problems. Again, it takes several minutes. It runs pre-flight checks and then do the update over all the nodes. From our experience and experience of our colleagues, both Talos upgrades and Kubernetes upgrades actually work without the problems. Of course, if you have some incompatibility in the API, you need to, pre-flight checks will fail, you need to fix them. There's no way around that, but then the upgrade just works. With one small asterisk, if you are using custom or more complicated networking, like custom CNIs, you need to hook into this system to not break everything. But if you are using the default Talos, it works perfectly every time. I just wanted to note that there's specific Talos versions only support specific Kubernetes versions. Usually when new Kubernetes versions comes out, in maximum couple of days, new Talos versions comes out. You can install it, upgrade it, and start using it. We discussed how to change the file system, but what if you want to change something in the machine config that we glossed over? Again, you can do it not only for new systems, you can do it on running clusters, and you can do it ad hoc interactively using command talos control edit machine config and node name. I would strongly recommend not doing that. Try to do even with Talos infrastructure as a code, and don't do ad hoc edits, and don't even edit the full generated file. Try to use patches and generate the files on the fly as you need them. For example, if we wanted to pass extra arguments to etcd to expose metrics which are not exposed by default, we would create a new patch. Let's call it etc monitoring YAML. We need to write this command, and then we would just run talos control gen config only now with config patch control plane. This is the only line that change. Given that it's at CD, we can change only the control planes. This will regenerate the files we generated before, and we again just call apply config. As we would call for a new server that would be then joining the cluster, we can call it for existing nodes in existing clusters. It will apply them. It mostly is smart enough to tell you if reboot is required or can be applied without reboot. This change is applicable before reboot, so it will just prompt you apply configuration without a reboot, and it will update the etcd static pods and apply this new line. So even changing configs for running clusters isn't very problematic. So even though you have immutable system, even running cluster is very easy with infrastructure as a code to change both the file system, the root file system, and both the machine config. Okay, what about other features? Is Talos truly managed like? Does it offer me the same features as a managed offering from the big clouds would offer? Scaling cluster up and down. This is extremely easy. When you have a running cluster and you want to scale it up, you just add a new node and apply the machine config. Or you can do the auto provisioning, and it will join automatically. This also works for control plane clusters. It will automatically join etcd and do this all stuff for you. Scaling down is easy as well. You just call talos control reset. Just a note, all those talos total commands have an API alternatives. It doesn't do anything else, that just calls API to the cluster. You just call talos control reset, and it will automatically remove the node from Talos control from Talos cluster for control plane nodes. It will leave etcd completely safely. All this is solved for you. The only thing it doesn't, for some reason, do is touch Kubernetes API. So you will have to remove the node from Kubernetes itself if you don't have some kind of cloud controller. What about networking? This is Also a thing that usually big clouds and managed Kubernetes solve for you. By default, it comes with Flannel CNI. You don't have to touch it if you are happy with it. It just works. So the default cluster that it will stand up for you is ready for applications. You don't have to worry about it. If you want to worry about it, you can disable the inbuilt CNI and apply any CNI you like Cilium or something like that. I would warn you that you need to think about the upgrades to not cut yourself out of the networking during the Kubernetes upgrades to have the proper ordering. And it has one special feature, that's kubespan. It has inbuilt mesh WireGuard overlay network. It will automatically by default discover nodes across multiple heterogeneous networks and join them to one cluster with overlay networking. This requires a discovery service. This is currently freely hosted on Discovery Talos Dev, and it's enabled by default. Just a heads up, this is one of components that you cannot run yourself without a license. It's proprietary license, it has business source license, and you have to buy license from Sidero, which are the guys behind Talos, if you want to use kubespan without calling home to their discovery service. And what about storage? That's not managed. Talos doesn't help you at all with storage. This is the one thing I think still needs to be solved for on-premise Kubernetes. That it's very hard to solve without big cloud providers, and Talos yet doesn't have any answer for it. Use a Rook or OpenEBS or something like that. But maybe even worse, the disk management in Talos currently is the state is not very ideal. The disk layout is hard-coded. You cannot do changes to it. It doesn't support Linux RAIDs. It doesn't support any kind of software RAID. If you want to have boot drive in any kind of redundancy, you have to use hardware RAIDs currently. They are working on it. Hopefully in next couple of versions, hopefully in next version this will be fixed. Maybe in the, but this is our biggest gripe with Talos at the moment. If you want to have HA, if you want to have redundancy for the boot drive, you cannot. Please provide at least 5 control plane nodes if you have to if you want to have reasonable redundancy.
Do you have to use UEFI? Can you use legacy boot?
Do you have to use or?
UEFI. Can you use legacy boot for Talos or just UEFI?
I think currently yes, and I am.
Latest is UEFI only.
Okay. Yeah, I know they said they will be dropping it. Currently it uses systemd boot and requires UEFI.
Is it possible to just hack it with privileged containers and run something inside the Kubernetes with privileges to modify the file system?
Yes, you. Well, no, not the root one. You have. If we look into this.
No, not the root one, but to manage some storage on different.
Yeah, for non-boot disks, it's possible. It even has modules for ZFS, BTRFS. You can do it for the data disk, not the boot disk. The boot disk are a single point of failures.
You want to answer the question, so please repeat them.
Sorry, I should repeat the question. The question was if I can hack it with privileged containers. You can hack it with privileged containers. It's not needed. You cannot hack the boot. The boot is immutably mounted. Another funny story with disk layout. There's this mferl partition. That's where all the mutable data are stored, including etcd data for control planes and downloaded images. Given that in our company we run it on bare metal, we sometimes do this not so nice thing that we schedule worker pods on control planes. You cannot split up etcd to different node, then download images to different partition currently, then where are the images pulled. So one of our problems we run into was our network is so fast, I know, first world problems, that we IO starve etcd during images download. You need to use very fast NVMEs if you want to schedule worker pods on control planes, because you cannot split the etcd to different partition currently. Hopefully it will be fixed. And with that, I am getting to end of my presentation. There's still a couple of gotchas. It's very actively developed. I know this doesn't sound like a gotcha. It's a great thing that the disk management will probably be fixed. But if you will run Talos, usually there are config changes needed with every version. The Sidero guys are very good about it. The deprecation usually happens over multiple versions, but things are changing. Like switching from group mostly BIOS boot to systemd UEFI only boot happened over like 3 versions. So it's production ready, or I would call it production ready. We run it in production for fairly big servers, but the config changes. So be prepared to read the update notes currently. The documentation itself, it covers a lot of use cases. There are how-tos, but it's not very searchable. The organization is kind of weird. And when you want to get a gripe of how all the parts fit together, the documentation needs some rework. And specific gotcha for metal servers. There's this special meta partition where you can store data that will live through Talos controller reset. One of the ways you can use Talos is that you will have inferral nodes that have prepared the initial boot image on the drive with prepared meta partition that has some basic config, typically networking. So if you have any specific networking, bonding, multiple network interfaces, or anything like that, you can store it in meta, and it's independent from the machine config. So you can join the nodes to some clusters, then reset them, clean them, and keep your network access. Because as it doesn't have SSHs, it doesn't even have local terminal. If you shoot yourself in the foot and lost network, you have to wipe the machine and start over. There's no backdoor how to get there from a local terminal. And the metal config is not checked. It doesn't have for dry runs. You are directly writing data to that partition, and if you mistype, wipe the disk. So that's one of the gripes we have with bare metal. And as I said, do not break network access. But even with all those gotchas, I think you should try Talos Linux. It solves a lot of problems, and we are happy with it. That would be all from me. Any more questions?
Yeah. We have more questions on Slido, so we can start. So I will just read it for you. So first, how to apply the config the secure way without the insecure flag?
I don't think it's possible the first time. After the first time, you will apply the secure way because you have set up the keys. I will find it. Here you don't have to have the insecure flag. It's only required the first time. I'm not sure if there is a way to set up it first time without auto provisioning. I would recommend you to do some. It has very many ways to do auto provisioning. In cloud, you can kind of hack your way through Cloud Init, where you can use the data, just paste the machine config, and it will set up it that way. Or you can pass kernel parameters with HTTPS. I think HTTP. I'm not sure if it validates certificates there. One other way, you can just prepare the disk image on special path, prepare the machine config, and again, during the first start, it will have the certificates, and it's secured that way. But if you are doing the easiest way, just boot up from the ISO. I don't think there is a way.
Okay, the next one. If a larger team manages the cluster, how do you keep, share, and distribute the sensitive pieces, like secrets and the cluster config of Talos config?
I think the same way as you do. And if I don't think I have any specific answer to this. It's the same with almost all of the systems. Secret management is hard. You need some other infrastructure to do it. You can do git crypt, Vault HashiCorp, but that's kind of out of scope of. I think we.
Do you use do you use sealed secrets or do you know vaults?
I don't think sealed secrets work for this because those are for Kubernetes. I'm not sure how does our team. I think it's safe in some password manager.
I think we can discuss it later because there are more people from the company. So
Yeah, as I said, I don't do it in company. Me personally, I use GitCrypt.
okay. Next one. Does it upgrade both control and data plane? Is there any blue-green strategy?
I'm not sure what's meant by data plane.
It's Kubernetes part that you can upgrade the control plane and then the data plane. I mean the worker nodes. So.
Yeah, it can. I'm not sure how is the current support for AB. You can stage you can even upgrade just like start the one command upgrades only the API server. The other one you can do part by part. I'm not sure if we can do like part of the cluster with AB.
And the second barber, is there any blue-green strategy?
I'm not sure about it.
Probably not. Yeah.
Probably not. Like
I just saw it in some, scalers. So I mean, hyperscalers that when you can buy their managed cluster, and there's something like that. But
I would recommend to have a second, almost the same cluster and test the upgrades there. My experience with trying to upgrade just parts of the clusters is usually everything breaks. So I wouldn't recommend it. It was
sure.
As if everything.
Next one. What about cluster API? Is there support for Talos?
Talos works on cluster API controllers. I think they are currently in beta. We can broken. They are working on it. I don't think it's quite fully stable yet, but they are working on their own controllers.
Mm-hmm. Okay. One. Is it possible to apply config part and just boot secure directly to something, not waiting to be initialized by someone, like using Cloud Init and so on?
Yes, as I answered before, this is possible, and it has many ways to support the config, because it supports many clouds and bare metal and very heterogeneous environments.
Okay. What if I want to provide developers access to SSH anyway to the VM?
You cannot. like one of the common hacks with debugging something is running the privileged container with all your tools, but the SSH is kind of the anti-Christ of this.
Does it require a reboot? Does it require a reboot of the node after using some privileged SSH container or something like this? I have to keep the node clean, the environment?
Well, the root file system is immutable. Even with privileged containers, you cannot modify them, so it doesn't require a reboot.
Okay. Did you test some other CNIs, Cilium, Contif, VPP? I think that you have it in the presentations.
On my personal side projects, I use Cilium. In our company, we currently are on the Flannel. I like Cilium. I am one of proponents of Cilium. And like eBPF.
And do you run it with clear version, like without kubeproxy and IP tables?
Yes, I run it without kubeproxy and IP tables. And
hey, you are smiling, but the hyperscalers say that they support the Selenium, but when you check it, you can see that there is still the kubeproxy and also the IP tables.
Yep.
So
here you can, even if you open one of the documentation is kinda complicated, but if we try to open their specific Cilium guide, and when you want without kubeproxy, specific guide how to run it without kubeproxy. And just a note with that, with upgrading Cilium, follow every step very precisely, do all the pre-flights or this will shoot you in the foot, and given that this doesn't have any escape hatches, if you if the network goes away, your whole cluster is gone.
Sure, perfect. I have last question on the Slido. So, what about local storage? No matter what do we think about it, can you use it and not want to commit seppuku?
Seppuku.
Seppuku?
Yeah, I understand. Yes, you can use it. I use it. Even if we in company use it. As I said, for data drives, you can even use something like ZFS or BTRFS. You understand me? You still can't use classic Linux MD, but you can provision multiple disks even with native Talos to have the mfile user data and use local provisioners.
Okay, it was last question on Slido. So, is there any question here from the audience? If not, I have the last one. I didn't see any mention about disk encryption. So how can I know secure?
It does support looks, LU. I don't know how to
and also secure boot, like encrypting the boot partition, and with the TPM chip.
I am not sure about that because secure boot is quite a new feature for Talos. I think they added it like 2-3 versions ago. But when I was in the
don't worry, we have second speech and he will be speaking about it. So not with the Talos, but
when I was
in general.
The image factory, you can select if you want to have secure boot, and they have the whole procedure of pre-signed keys and how to sign the extensions. I didn't look that much into that. It's quite new, and I must say I am still afraid about secure boot.
Yeah, so, I get it.
They do have some support, not tested.
Okay, so thank you. We have 30 minutes break, and in 7 p.m. we will start the second talk. So just grab some food.
How many minutes break?
13.
13.
Yeah.
Oh. Yeah.
It's my watch, so yeah, it's 12 minutes.
Okay. Then in the meantime we can set.
Yeah, sure.
Doufám, že jsem.
Perfektní.
Doufám, že jsem byl tak správně hluboko, jak jsem byl.
Ty bys měl být, jo, naopak skvělý, protože my jsme měli minulý měsíc talk o Talosu, o člověku, který do toho kontribuje, a bylo to mnohem horší. Jakože že tohle je úplně skvělý pro lidi, co to už neznají, ale zároveň to bylo dost jako deep dive. A mimochodem skvělé, jako prezentační skvělé, to se mi fakt jako...
Děkuju. Mě tam angličtina, jako, já mám problém s tím, jako degeneruji, skoro jsem horší a horší.
Ale i tak ten projev a celkově je to jako skvělý. Fakt to jako, musím říct, že to jsi jako jeden z nejlepších speakerů, co by to měli.
Super, děkuji. Tak,
Did I left it here that you use with me?
Pavle? Nevíš, kde je ten dog tady nějaký?
Dongle. Here you go.
Ne, ale...
Yeah,
Oh my god.
wasn't mine.
I was scared. So, not this one.
You can use
Okay.
Dobrý to?
without,
To je skvělý.
děkuji za pozvání. Blbý být poprvé nemít takhle mluvit. Vždycky si je takový jako vytrapný, že jsem byl někam jako na sílu injektu.
Ne, to je v pohodě.
Tak já příště se pokusím přijít. Je těch akcí strašně moc.
Je jich strašně moc. Ne, je to
Jako já chodím reálně na naši Meetup, to skoro ne.
No a já jako jsem docela rozlítaný, takže to...
Okay, it works.
Yeah, it works even if outside.
But I have a little bit. I may hit this. Can we move this cable
Yeah.
to me?
I think we can move it. This is our internet connection.
Oh, really? Oh, we have a Wi-Fi now?
But do you want to stay here?
I can give you...
No, it's okay. I think. No, it works.
Yeah.
If
Perfect.
we don't see any slide with like a loading bar,
This is for you.
should I keep it there? Or?
Yeah.
Now
will
it's
be the
muted,
best.
you can have it, but you cannot go there, so if you want to go there, so leave it
No, I will
here.
just try it. So my hands will get used to it.
Yeah, we should try that. The sound is good.
Jo.
Pavle, jakou ty máš?
Yes, of
I
course.
am really not trained for
Pavle,
this.
jakou ty máš velikost?
47. 47, 48.
Ah, okay, now I get it. So can you test whether it works?
Say something.
Say something.
Yes.
Okay, cool. Just
I will have it
And
here.
before the start, I will
I will have
unmute
it here
it.
now.
Okay.
I'm gonna go toilet or something. Now people will hear.
Okay. Tak jo, máme ready do Meetup. Nikdo nemá ponožky. Já mám 47,
Já jsem říkal, já mám 48.
nikdy 48,5.
To je pro mě.
Můžu si dát dvoje.
Tohle je moje, víš, to je jako...
To je moc velký, ne?
Ne, no.
Spíš vadí, že jsou...
To mě nevadí. Ale ne ponožky.
Ale víš co, musíš si vzít ponožky s pivem, to je základ, že?
Lepší ponožky dál na Pirit, oni mají 47 až 50. Oni fakt mají potu velikost víc.
No, protože jejich síťou je velké,
ale je menší než já.
pro ně, pak udělat 5 párů, že?
No.
Jo, pak tam přijdu, já máš zase všechny vody.
Tak to kolik takových lidí je, že jo?
Jo, dáme to.
Jako všechno, co podporuje Strike, tak podporujeme i my.
Tak já bych si vzal tohle.
To je pro sebe nebo pro ně? Ano, to jsou naše videářské.
Já jsem vždycky, když jsem testoval to, já jsem testoval, jak to vypadá,
To právě jako všichni to znají, že my na to jako trochu mínujeme ty jako videářské. Hele, tady je obvěz.
Jo, ty vole, to je ještě lepší. Protože to se hodí naše meetupy, tohle to je skvělé. No tohle by bylo lepší, ale
Ty se rozhodnou. Bitrate už nemá.
A ta je napojená na
no hlavně tím, jak máme meetup, jak je to právě jsme ideální, protože já vidím, jak to tam trochu je. Protože to mobilní
Máme štěstí, že se nechodí.
Tak se vezeš, jak je stále,
to vypadá rozpadá.
jako máme
Stále se najíst.
jeden protokolik, a i ty PAS velký, tak je to úplně skvělé. A je to tady se zároveň někde napsaný. Jo, fakt nevím. To je dobrý. Teď někdy vlastně máte tam.
No jestli, tak to je dobrý.
Jasně, to je, když jdeš na konferenci.
Oni už jako docela tam
To vidíš. Jasně, no.
tam už jsme s tím jakoby, se někdo si myslí, že to je určitě. Máte nový trička?
Ale ne, jakože na fotku.
Tak si je vezmi, protože já měl jsou.
Říkal, že mám 50.
Ne, tenhle kotníkový. Normální, jo, ale kotníkový ne. Oni jsou krátký, takže já vlastně mám kapitánu.
Ještě stejně.
Ne, jako já si vezmu dvoje tyhle. Ale tričko si nabídnu. Protože to je skvělý. Udělat reklamu. Dobrý.
Jasně, ale to člověk prostě, to jako nenaplánuje, ale dneska je ten mystický význam, dneska, ale to prostě jako netrefíš, prostě to je jako v pohodě.
Já s tomu můj téma dělám.
Ale úplně, že co děláme takový hack, že já přesně extra host, jako, ale to já bych se tak tam prostě do já bych se kakal s tím, že mám prostě jako input, ty nový IP, tom svít díl, co pak jako používá Talos a samozřejmě komponenty, přijde třeba CNI, tak je local hosted už 445, to je prostě nějaký load balancer, který balancer všechny ostatní domény. Takže vlastně přes tu tvoji doménu snad Kubernet endpoint, co lidi volají zvenčí.
Jsme inkluzivní, ale máme bandlist. Jasně, řekne, že den před akcí,
Dál mě to mám nakoupený, ale prostě když se jedno vyjaduje, tak to jako
Já ještě můžu vzít tížka, M-ko.
A druhá, to není vůbec tomhle formát, je to taky, že já tam většinou minulý tam jsem myslel, stál jsem učil, ale uděláme si a minulý rok jsme si zaplatili
Ale Zenko, máš 2 minuty, tak je pak jdi přeslat a...
Jak se jmenuje to, když jsme měli minulý rok ten
Jimi, přístav 18600, jak je holka, tak ta...
to bylo úplně skvělý,
Jo, to je super místo.
Já jsem to rezervoval, to je to největší.
Dá se to už rezervovat.
Je tam grill, já jsem nakoupil, teď už jsem byl na kruhu, jsem koupil všechno, co potřebujeme pro jídla,
Dá se to rezervovat, můžete si to klidně vzít v Volkswagenu.
My hlavně tenhle event většinou děláme jako bez sponzorů. Lidé můžou přijít, ale že máme nějaký prachy, co rozdělit. Já si to koupím. Navíc říkáme, jako, chceš něco extra, tak si to přines. Prostě kdo tam bude, ale přines si sám. My jako zajistíme nějak. A ten přístav je skvělý, že tam to otočí pivo.
právě, no, že tam je tu píku. Jako cenově tam docela normální, 50 závod, ale jako takový za 70 korun za palek, to je.
Já jdu nahnat, zpátky.
Možná trošku, no. Já jsem Pavel. Já dělám AVčko, si možná všechno, dělám stream a myslím, to všechno dělám já se někde, ten malý a agresivní. Jo, já vím.
Ale tohle technologie,
je to komunitní, no, což je jako super, jako žádný korporát, nechcem řešit prostě žádný hudna. Prostě bude to tady, přijďte to část, to to téma. Jo. Ale obzvlášť, co jsem slyšel o party. Jo, jako jo, to jako přesně, jo.
Guys, do you know how to make this silence? Not to get notification?
Yeah,
Thanks.
Zdeňku, když tak můžeš pak lidem říct, že tam vzadu jsou deky, že některým začíná být zima. Tak jenom jestli to budeš moderovat, tak jenom to se.
jo. Už jsem měl i lepší dnes, který není kritický. Ale
já teď začínám vyšťuchat vývoj tiskárny.
Jak kolik to
Okay, before we start, there are blankets. To ještě není u toho. There are blankets, so you know.
Of course. Is nějaký online?
Which one do you think better?
Oh, probably this one. Jo, můžeš. Should be okay.
Okay, we will continue. So there will be a second talk by Emrat about the secure root and TPM. So the stage is yours.
Thank you, Zinedek. Good evening. So, secure boot and TPM baked full disk encryption. Don't let the title scare you. This actually contains multiple subjects. You might be familiar with that. Not only that, you may actually even apply it on your Linux installation, on your environment, secure your setup. What I try to do is actually what I attempted, put multiple things together, and top of that, I try to enable secure boot and integrate the whole system with the TPM, which is the module I will also briefly touch. Prior to start the talk, actually, I would like to refresh our memories, how the Linux boots up, which could be quite relevant. Well, we can start the powering on the device, and there will be an initial check takes place. The hardware components will be initialized. I think you can include maybe keyboard, mouse, but also you can exclude them, because you may even access this device via KVM, so even maybe monitor is not connected. And our focus is basically be sure that hardwares, most importantly hard drives, storage units actually, are initialized, and specifically one where the operation system installed, so we can actually boot the system up. But at first the bootloader must be loaded. And here I didn't choose arbitrarily group bootloader. It is significant, and UEFI is also significant. I will also touch them later on. After the bootloader is loaded, kernel will be loaded, drivers are loaded, and system services will start, and then the user space will be available for the user. However, if you just pay attention to the highlighted bold text over here, verify signature using secure boot. So during the early boot, there could be one more check, one more verification actually may take place. What is it could be the secure boot actually if we enable it. And what it does, well, it basically ensures that the group bootloader, the bootloader in general, is verified and also prevents unauthorized modifications. So what does this mean? Well, let me actually tell you how the secure boot first works. Well, there are two ways it can actually kind of operate. One way, well, we can consider is the out of the box way. Regardless whether it is enabled or not, there are, if you check the UEFI, you can find where the keys are located there and stored. You will see that there are already signed keys and generated keys and signed, and these are the keys will be actually handled basically the secure boot. In other words, trust chain will not be owned by you. Trust chain will be already done by the secure boot. Actually, the Microsoft will handle this process, especially by signing the shim, which will be significant in a moment. The other approach will be that, well, basically, you are not using these generated keys, and you are generating your own keys. If you look a little bit more deeply, so I already mentioned the shim and the Microsoft. So actually, Microsoft behind the shim and signs the basically shim, and but what are those keys? Well, we have actually kind of four categories. One is the like public keys, key exchange keys, and the authorized keys. There is also one more. I will get into that later. So DB is basically stands for the authorized keys. So what happens? Well, we are actually creating a trust chain. Actually, trust chain is already exist, signed, and we are just basically using it, relying on it. But there is one thing that we can do. We can actually use mock-util. After the operation system up and running, we can actually a little bit modify this trust chain, but we have a limitation. We don't do any other things. We are just relying on the existing keys generated by Microsoft and already signed EFI binaries, and as well as the kernel. In fact, if you check the kernel and the EFI binaries, you will see one or two certificates there. One could be from the Microsoft, and one could be from the operation system, for example, from the Debian. On the other hand, if you want to go to like a full ownership, then what we can do, we can actually replace all those keys by the ones we are generated. So in this case, we are actually basically deleting all the keys, public key exchange key, authorized keys, and maybe, as I said, there is one more category, and then sign EFI binaries as well as the kernel with the ones we are generated. So here we are actually owning the whole trust chain. And you can actually see the comparison to each. So as I mentioned, shim is actually kind of important here when it comes to the default approach, where the shim is signed by the Microsoft. And if you go to customized approach, where we are owning all the keys, and we are basically excluding the shim, and then it starts still the same. We still have the same number of keys or the same type of the keys, but the verification process is actually now owned by us. Basically, we are owning the trust chain. So my presentation will be quite fun because I'm going to quite hands-on, and I also learn this subject as I go. So I will show you the bunch of commands here, and I will try to also explain why I am using them, on what purpose. And here, actually, if you want to, for example, enable the secure boot, and you need to install some packages. Because I do experiment with this, there are more packages here than required. For instance, UID runtime may not be needed. You may come up with your own way to generate your UIDs, or you may have already some implementation mechanism. But the mockutil is necessity, because we have to use the mockutil to verify the secure boot status, which should be disabled, and also it should be in the setup mode, which I will also tell you how we can do it. And after that, well, in order to organize things, because we're going to create many files, and in order to keep things organized, I recommend you to create some folders. This is not, again, like a necessity. You can do this in a different way. You can place them in another way, in other places on the machine, but just don't forget where they are. So as I have mentioned, you need to disable the secure boot. So this is maybe not the same on every machine, on every device, but you need to find the secure boot, and then you need to disable it, and then you need to actually go basically delete all those keys. And here you can see also forbidden signatures, which is called DBX. This is kind of preventing for malicious software to be executed on your system. Not only after the operation system is booted up, but prior to that, during the early boot too. Because there could be maybe a malicious software during the early boot and try to connect the internet or something. And I will talk about relevant things later on. So it is up to you. You can actually delete it, or you can come up with your own forbidden signature as well. So now this is where the fun begins. So first of all, you need to create platform key. Oh, I actually the public key, right? Yeah, okay. It's a platform key. You need to create platform key, key exchange key, and the authorized keys, along with their certificates. Here, the subject, you can see I just put there an example, but you can actually enhance this. You can actually a configuration file, and you can actually target the configuration file, and then you will have more detailed certificates, like the email address, expiration date, multiple CN. This is just the simplest way, so I can actually talk about this. But you can actually improve this basically. And after that, and again, generating the random keys, I am using in a command. Again, you can actually generate it in another way, but it will be better to actually create one UID and then keep it, and then you will use the same one later on. So the second step after generating these keys, basically generating, also converting the certificates to UEFI signature list. And after that, you need to also create sign authentication codes. And after that, again, you can actually work with to unauthorized ones. It's kind of up to you. I haven't actually practiced that. I basically deleted it during my experiment. But the most important thing, silent the kernel. So here you can go strategic, because when you have the operation system, you may have one kernel there already, of course. But then later on, let's say you have Debian and you're gonna update the system, and you can see there will be another kernel, for instance. So you need to sign them. Well, you can actually sign them both. How many kernels you have, you can sign them all of them, or you can just make sure that only recent one is the signed. So the previous ones, if machine some reason try to boot up from the old kernel, then it will not work. So you will have all the control of how the operation system boot up and what kernel, which one, and should be basically allowed. Again, it's a strategic decision. You can sign them all too. So now, after that, basically, you need to actually sign you sign the EFI binaries. So here, I am also signing the shim. You may exclude it. During my experiment, I actually wanted to be sure that everything works. So I sign basically all the EFI binaries. But some cases, I have observed that if you delete the shim, you may get some error messages during the early boot. So you may need to little bit experiment with that. But one thing is important. These EFI binaries are not, let's say, empty because they are already signed. Again, they might be signed by the Microsoft as well, and also there could be a signature on them comes with the direct operation system. So at least there will be one. So you can actually check it. What I'm trying to do by running these commands, basically I am trying to actually create empty ones. And the reason I try to do empty ones, because you cannot directly actually add another signature on them. You cannot sign them. You need to basically get rid of the existing one, create an empty one, and then you will be allowed to sign them. After that, in the last commands, I am trying to actually get rid of all the empty ones. So now we have already signed them, but this is not going to make an impact on the system because we basically enroll these or custom generated keys to trust chain, into the trust chain. So there are two ways at least we can actually enroll them. One way will be basically running the EFI update var, and this is where this path comes in handy because you need to basically access the out folder in that path and then target those files. Or you can use the secondary command, but if you use the SB sync, then be aware because you need to run it 2 times. At first try, it will only enroll the platform, it will not enroll the platform key. You need to run it second time, and if you try to enroll the platform key, you may get some error messages. If you don't get an error message, it may look like it worked. I tried a couple of times. I am not 100% sure whether because I tried to enroll the platforming key first, but basically it will behave unexpectedly. So it will be better to actually follow these steps and then enroll all other keys and the platform key first. So far we are talking about the secure boot and owning the trust chain with our own generated keys. However, this is just will apply during the boot process. What if our data integrity? Machine will boot up and we have the system up and running, we have our data. When it comes to protecting that, we can also talk about this encryption, and fortunately Linux already support LUKS2 out of the box. So it's quite detailed. There is so much actually configuration you can do. I'm not going to get into detail, but I will just bring your attention. LUKS2 and LUKS1 will be relevant to us, and for now I am just focusing on the LUKS2, but later on I will also mention the LUKS1. So here basically what I'm going to do, yes, you may even see the password here, 1235 is just I put it there because I wanted to show you how the command works. You can also come up with your own automated way to generate very secure password. But basically what I'm trying to do, try to format a partition on the hard drive and encrypt it with the LUKS2. And then set a password. And then I open that encrypted hard drive so I can format it. After I format it, what I need to do, I need to actually have add this to crypto tab. So if you have a hard drive, a partition, it will have a UID. But if you encrypt it, and then its UID will be different. So in order to actually operation system to know that there is an encrypted partition on your system, you need to have that edit the crypto tab. If you don't do that, if it is not a boot partition, machine will boot up, but then you need to go manually actually open that encrypted partition later on. So putting here the crypto tab will basically, it is sort of necessity, and you will not like block yourself out from the system later on. But again, the system will boot up because boot partition is not encrypted. but it will be better to put here. And then you need to definitely update the init ramps. And if you don't do that, you may get some error messages. System may not boot up. Also, this configuration could be different based on your needs, because different based on your needs. So I would suggest you just check how you can run init ramps in a different ways. Most importantly, even though here these steps you can follow to encrypt a partition, I actually don't recommend this, because if you have an operation system already installed, it is really dangerous for you to encrypt the system while there is an operation system there. So it can cause a problem. It can cause like a data corruption, and even though you do everything right, operation system may not boot up. So maybe I cannot give you a statistic, but it is not ideal way to do that, unless you are really sure that you are backupping everything and restoring it. But it is unnecessary too much work to me. The best practice, I think, you can do this during the installation process. You can just, for example, follow the UI or the command line during the installation process and choose the right option for your needs based on your needs. However, and this could be a little bit tedious process, because if you want to do it multiple times, I recommend you to create unattended installation. This actually makes life much easier. Debian has a way to do that, which is sort of nightmare. The configuration. I think Archlinux is way better, but I focus on the Debian. And basically, you need to create a, I guess called preset config file. You need to play with that, and you need to come up with your own configuration. And in the end, you will actually have LUKS2 encrypted system installed on your machine. And then what will happen after that? Either way, when you reboot the machine, you will be prompted with this to tells you to unlock the hard drive. So this is after the boot process. Actually, this is after the early boot process. So machine is about to let you to user space. But every time entering this could be, I think, annoying, and you may not even access the system to do that. So you can also automate this process by generating a key, which securely can be kept actually under etc and keys. So there are various ways to you can generate these keys. This is just one way. And the most important things, after you generating this key, you must add the you must add it using the crypto setup, and then after that you need to also update the crypto tab again. So previously we didn't updated it. We only actually updated the crypto tab to tell the system, hey, I have an encrypted partition here, and be aware of that, and basically tell me to unlock it. But now we are not actually doing it. We are basically telling it, hey, I have an encrypted partition here. You don't need to tell me now. You don't need to prompt it. This is the key file, and this encryption is actually takes some time. And the way I see it, based on out of the box, when you do that, if there is no any other key edit using the crypto setup, then it will be in the slot 1. So basically, you can target the slot 1, and it will speed up the encryption process. And after that, again, you need to update the init ramps. As I have mentioned before, you can check the configuration for the init ramps. You can do it in a different way. So basically, you might not necessarily need to use the all if you find the more relevant configuration for your needs. So now this is actually gets much interesting. We were talking about encrypt maybe the rest of the partitions where the operation system, where your the data are stored. What about the boot partition? Can we encrypt that? Yes, but the most important thing here, we cannot encrypt with +2. At least the way I found out, based on my experience, my experiment, it didn't work. Also, I kind of found out that it is not supported. It only supports the LUKS1, not the LUKS2. So maybe there is a update. Now it supports LUKS2, but by the time when I was actually working on it, I had to do LUKS1. So basically you can, yes, encrypt the boot partition, but you must actually remount in a only readable way, because during this process nothing should be written the boot partition. So basically you can backup in it, and then after you backup it, you are still following the same process. You can see here more commands. These are just actually for you to kind of know. You can actually come up with different, like a configuration. You can enhance this encryption process, again, based on your needs. And here is a significant part is the looks one. So after that, you need to format this encrypted partition, which is actually our boot partition. And after that, you need to restore. And after you restore, you can actually go and check the f-stop. I didn't actually see here, but you might need to also go to look at the crypto-tab as well. I think that part is missing here. So basically, you need to be sure that when you are encrypting anything, UIDs are changing. If any place on the operation system that UID used, you might need to go and update it too. So this encryption, and if you do this, this will not work. This will not work because you need to actually enable it. And the only way to enable this, which I learned from the hard way, because I did this and I was very happy about that, then nothing worked. But luckily I got an error message, says that error message, it literally tells this one, group enable crypto disk. It literally tells the same things. You need to enable this. Okay, so it is not actually kind of complex process, fortunately. You just need to update this. In other words, you need to enable this in the configuration, and after that you need to regenerate the configuration. But later on you need to now install the group again. So here's the tricky part. Here you may see, actually I am pointing at path boot EFI and EFI, and I use Debian. The reason I use Debian because I did this on Debian operation system. I also tried on Ubuntu, didn't work. But if you, let's say you're trying on Ubuntu and everything works so far, and when you come here, don't put there a Debian because Debian may not exist. You may have another distro, so you need to go and check what you have under the EFI, and you may have multiple. You may have Debian or maybe something else, and you need to basically tell the group install where you are installing the EFI binaries, because if you don't, it may create its own, and then things may not work, and you may actually kick out yourself from the operation system, and it will not boot up because it will not find the EFI binaries. Then you will end up in the group rescue mode, and it's not fun. So if you get here, and if everything is done after rebooting the system, now it will tell you enter the actually passphrase right away after the all initial check is done. So basically, during the early boot, you will actually get this. It kind of looks funny because you can see like some like logo, some maybe messages comes from the factory settings. You can see the hard drive are like initialized, and then suddenly you will see enter the passphrase over there. So it kind of looks UI wise not like visually tells you to enter. So just pay attention. The text could be a little bit broken. And this UID is actually kind of significant because you will see this is one of the configuration file. Now, it is also kind of not, I guess, convenient to enter the password every time when you boot the operation system. You can also automate this process. By the time when I was actually working on this, I used a group 2.13. However, either 2.6 or 7, I might be mistaken, but one of the earliest version also supports this. So what I mean by the support this, this is kind of fun. When you install the Debian, you can still boot, encrypt the boot partition, but you cannot do auto unlock because it just so happened there is one binary called, I guess it was the crypto disk, and it doesn't support auto unlock. So you need to build the group bootloader from the source code and reinstall it. And if you do that, you will have the updated version. When you have the updated version, this binary will come with that feature, so you can actually unlock the boot partition without entering the password. And again, the 2.13, it supports this version, supports this as well. And I actually kind of recommend not to use this one because this is kind of heavy. It comes way more features. And basically, if you just only need to unlock the boot partition, like automated way, then look at the most recent, earliest version possible. So basically you need to download the repo, and based on the documentation, these are the steps you need to follow in order to actually build the bootloader from scratch. And there are some modules. These are the modules are required because when you build the group bootloader, these modules will be basically included. There are more modules you can have, but these are the most important ones. So after you reboot, let me see. Yes, automate unlock. So you reboot, maybe, yeah. So you reboot and it will still prompt you to enter the passphrase. That means anything you have done here worked. Nothing is broken. Machine still can boot up. So this was like some sort of like a security check. But you wanna basically automate this unlock process. So what you can do, you can basically create your own custom group configuration. In order to do that, you need to basically edit or generate this group file. So question mark here is actually the things I am trying. I have been emphasizing since the beginning. These are the UI IDs. Either you can put the UI IDs or the name of the partition. Like if it is encrypted, it could be maybe like a SDNX encrypt. So you are putting there the encrypted UI ID, and then the set prefix will be the one after the encrypted partition unlock. So you can actually go cryptotab and the fstep. In those files you can see fstep is the encrypted one, and the cryptotab is where you can see the UI ID for the encrypted partition, and after it is unlocked, it has a different UI ID, and which will be in the fstep. Or you can use the name too. Actually, you can use the name in the fstep. After this, now you need to basically embed this generated your custom configuration to the EFI binaries. When this is done, when you reboot, you will see still the same prompt, but after that slot 0 open. So basically you will no longer need to actually enter the passphrase. One disadvantage is this. When you do that, I actually spent like I guess 20 days on this to figure it out. You broke the secure boot. The reason is that you are intervening with actually the of the EFI binary, and even though you are generating EFI binary and signing it later on, secure boot is basically not happy about that. So I have actually tried various different ways to find out. I haven't actually figured it out. Couple things I'm still trying on. As soon as I found out, maybe in another talk I will let you know. So you need to prioritize things. So far everything works, but you need to prioritize. You need to secure boot, or you need to have boot partition encrypted. So we have now encrypted the hard drive, completely. The partition where we have the operation system, where the data, and also the boot partition. But we can also enhance this, enhance the security using the one module called TPM, a Trusted Platform module. This is basically we are shifting from the pure software security to also hardware security. This is a small module. I guess laptops also has it. You can laptops also have it, and you can see it actually whether it is enabled or not on the UEFI, and you can enable it or disable it. But even though it's enabled, even it is there, in order to actually use it, of course you need to install a couple packages. And well, this is for the only TPM2. There's also TPM1, I suppose, and anything I do here should work with only TPM2. So you can basically install the required packages, and you can check the version, and after that there are various different ways also check the status of the system. And if you just look at here the TPM2, and this is a significant one, because maybe you have the TPM1 and then you will not actually see here because you are already installing packages for the TPM2, so it will not support completely. And I just have this here just for you to know basically, and during my experiment I needed to find out to get familiar with the TPM, how it works, what can I do with it, and I was basically running various different commands to see whether I can see anything relevant to my work. So you have the TPM and you checked it, it is there and it is working. Now what you need to do, you basically own the TPM, because you can actually use the TPM without not in ownership, but that will basically security breach, because as soon as operation system is boot up, anyone who can access the system as a user then use the TPM, and that actually kind of diffuse the whole reason that why you are working with the TPM. So again, of course, you need to have more secure password here. In fact, you don't need to even enter this password. The almost everything you have seen here so far automated using an Ansible. So after the operation system is securely installed, I basically run the Ansible playbook. It actually handled all the whole the process, and also generate all those the password. And I also use the Vault, so I don't even like see what passwords are generated or used. So you can own the TPM, and after that you can actually start to play with it. Let's say you have one data sealed. So this is actually important, because I say sealed, not encrypted. You may have already an encrypted data, and what you are doing basically, you are sealing this encrypted data or the data you have on TPM and keeping in one registry. So it can be a text, it can be a public key, which we'll actually also talk about a little later on. So we are basically creating a primary key, and then you are using this primary key and load the data to volatile memory. What does this mean? At this moment, after it is loaded, it is there, but if you reboot the system, it will be gone. So in order to persist that data, you can actually use another command and your password, the ownership password. So basically, you can persistent data. And here, I am actually explicitly mentioning what address I want to put in. And then when I see it, it is persisted in that into that address. What if I want to unseal it? So, because it is persistent, it's in the non-volatile memory, I can basically get all the persistent like addresses that in use, and then I can actually unseal what is there. And then if I wish, I can also basically remove the persistent handle, or the basically what is there. So this is just a quite minimalistic way actually work on it. We have also a TPM also support the policies. I guess it's configuration registry. I don't remember what the P stands for. I guess a configure registry. So basically, you can create your custom policies. So this is the part that's a little bit tricky, because these numbers are here actually corresponds to policy. Each number actually corresponds one policy. If I collect the 7 correspond to secure boot. So what does this mean? Basically, you can put there 7, and if the secure boot is enabled, and later on if you disable the secure boot and you have TPM set up using the policy requires 7, then it will not work. So basically, you will not be able to unseal the data, because the policy now is not matching with the configuration. The previously the configuration, because you changed, for example, the setting. And the other numbers here also indicates the other settings, and there is a list for that. I guess there are either total 15 or 20 settings, and this is kind of not only just it is one thing, not only 7 is the secure boot. We talk about the secure boot, but it's a trust chain, and the trust chain is not just necessarily one thing verifies the another thing. You can also consider this like one thing verifies the another thing, but then 2 other verification needed to be done. So it's basically you can consider actually the hashes. You have EFI binaries, you have kernels, or even though they are signed, even though secure boot is enabled, and they are signed with the keys that you have generated. Let's say you updated the operation system. Now kernel maybe got changed, or you copy a file from another operation system, exactly the same EFI, and sign it. But the hash will be different. Because the file hash will be different, one of these policies actually will be still the problem for you, and it will say it will prevent for you to actually unseal the data. So you need to pay attention what policies are using in what order also, because some policies will be applied during the early boot. Some policies will be take effect after the operation system almost boots up. So let's say the late boot. So here what I'm trying to do, basically I'm trying to start a session. Why this is important? So I am creating a session, and during that session I am also creating the policy, I am generating the password, and then I am basically getting rid of this session. So after that, I can actually create a new primary key and seal data. So after data is sealed, I can still load this data, but if you want to unseal this data, I need to create a session again. So this put maybe some sort of one more level of security too, because you may not know whether session needs to be created. And in that specific session, only in that specific time window, as long as the session is like let's say started, exit, I will be able to use the policies and unseal the data. And of course that after that I will flash the session. And here's the thing, let's say during that time you started the session and you put there, let's say 7, and you didn't configure the 7 previously, so 7 was not here actually, it was not there, and then you put here 7 during the actually sealing process, and then you will get of course an error message because the policy now is not matching. You cannot continue after this moment because now you you need to create a session again. So this is kind of actually makes things a little bit more challenging. So every step, everything should works. So basically, if it fails, you need to start the session again, and you need to write actually the numbers here. So you can then after that you can unseal the data. But everything here you have done still required maybe manual work. What if we can also automate this process and maybe have it done without like a user interaction? So in Linux we have an option to actually come up with custom initram, basically configure the initram. This is quite simple way to show you. It's a little bit actually require more explanation, but if you go look at this part, it's in initram tools, you will see scripts and the hooks here will takes place before the scripts are executed, and there are scripts basically that are like a 6th level. So 6th level, and it will take in different time at different time during the early boot. So based on your needs, you can actually create custom scripts in order to do some operations. Because during the early boot, as soon as initram is loaded, you can actually access the internet too. Maybe you need to pull something, for example, a fetch a secret from a URL, or make request in an endpoint, get something, it will be possible to do that. So here there is some configuration. I actually kind of play with this, but so far what I found, this is the way to go. So if you change it, it may not work. This basically how it's supposed to be. So this is basically you can consider as a template. What I do though here though, so during the initram, well, you can consider this bare minimum operation system. There are still binaries that can be there, and you can use that binary, so you can execute stuffs, but you need to have those binaries available. So you need to basically binary by binary, you need to define them and where they should be. So let's say you need to use load external. This could be any binary, by the way, like for example mount, so or build ID. So if you need those binaries during the initram process, you basically need to have them available there. And there it is again the syntax of the this script, so you must have that there too. So basically what you are trying to do here, you are ensuring that these folders will exist and during the initram with this actual permission. So why I am doing all those things, so my goal is here actually one more thing, as I mentioned the scripts, so there are multiple scripts and they run in different different time, and the one I used was the local tab, and I just want to be sure here with this implementation local tab runs last. So firstly the hook script must be executed. So I have all those folders binaries ready for me, and then the anything in the local script will start running. And what I do here, I do basically we can also debate about using hard-coded UID, but my point is here, be sure that I can actually have USB drive with this UID and mounted this path. So if I don't here have this mount binary copied, then during the initram process, when I use this when I use the mount, it will not work because it doesn't exist there. So that's the purpose. Now I can use it. After that, what I'm trying to do, basically what I'm trying to do, actually, I try to get a file there, which I didn't mention here, but the purpose is here. Basically, during the early boot, you can have like some sort of maybe a public key, which is actually stored in the USB drive, the specific USB drive, and then you are sure that this file is needed, and then you can integrate with the TPM to, for example, we have policies, we have the key, and you can actually customize this process, and you can make sure that only this public file will be used, and then you can unlock, for example, the encrypted partition. So here the goal is here, make everything fully automated. This will take after the early boot, after the boot partition is decrypted. So we are not actually doing anything for the boot partition. If you encrypted boot partition, it will be still encrypted because we already actually embedded our configuration to EFI binary. So that will work, and group bootloader will be loaded. But what we are doing here is for the second part, basically, where we are entering the passphrase for the rest for the decrypt the rest of the hard drive. And you don't need to necessarily, of course, work with the TPM. You can have a file which contain a text, and you can use the text basically to unlock the encrypted partition. And I have a fallback here if something goes wrong, and then it actually prompts. If you don't do that, it will not prompt you. So I am basically enforcing the system to prompt me if something goes wrong. And here you can see the key file. Previous slides, you may have seen that we have the key file, etcd keys, which actually unlocks the partition. And instead of, for example, using that key, you can actually keep the key file here. And then this makes like some sort of, little bit more enhanced security. You must have the USB drive plugged on that machine. If it is not, system will not boot up, or system may be boot up, but you will not be able to access the operation system, and user space won't be available. And after that, everything you do here is actually takes place after the operation system boots up. So because you are basically creating script file and placing there, and after that you need to update the initram again. So everything goes well when you boot up the system. You will not see an error message, but I still recommend you to not to do this at once. What you can do, you can basically kind of have fun with it. Just have one USB drive, know the UAID, and then basically put there a couple messages. What will happen when the machine boots up? After the early boot, you will start seeing your custom messages, and you will know that, okay, everything works. Because some reason maybe the script in the local tab will not work, and you will need to know that. Otherwise, if you are like depending on this right away out of the box, you won't be able to maybe access the operation system. So it was not scary at all, right? Thank you for all. If you have any question, please don't ask.
We have some questions on Slido. So first, did you try any automated solution, like for example Clevis plus Tank or systemd crypt and roll?
Yes, I tried both of them. Maybe because I couldn't figure it out. Clevis seems actually simplify like maybe 30-50% of this process. It takes over some responsibility, and you don't need to configure everything. But I couldn't just get and set it up on Debian. But if you can figure that Clevis, yes, that's actually a really, really nice way to go.
The second question is, was there any restriction to decrypt disk in offline mode? Or what is the reason to not get the decrypting key from the server via secured connection?
You can actually get it, but you need to, it depends where you want to do it. During to like an early boot, if you configure the initram, you can access actually remote source. You can actually get the key, for instance. You can unlock the partitions, and you can just get rid of that key. This is about the basically your decision, also capabilities, and the know-how you have. Like what you would like to do. This setup is focusing on on-premise, but also offline mode. So USB drive, that's why is used, and you are not accessing the internet.
I see questions. So
Hi Emrah, I'm Otakar, and my question is: you first went through like decrypting the disk and encrypting the disk and encrypting the boot partition, and then you went to automate the process, so you don't have to put in the password every time. And my question is: when you automate the process, then I suppose the decryption keys are stored in plain text somewhere on the device, and if someone stole the computer, he can see the keys and decrypt the drive, decrypt the boot, and basically my whole journey would be worthless.
Yeah, I understand. What's the purpose keeping there? So they actually cannot, because if you encrypt the, let's say you have the boot partition and the rest of the hard drive. So you encrypt the rest of the hard drive with LUX2 and the boot partition with the LUX1. So you are keeping the key, right, in the, let's say, etcd key folders. And if you have the hard drive, and if you plug in another machine, you will have two partitions. One is encrypted with LUX1, second one encrypted with LUX2. And if you have some like a, I don't know, very fast machine, unless you have it, you won't be able to actually decrypt it because it's already both parties are encrypted. This is actually a really good point because this is how you hack system. Momentarily, things are actually unlocked. In fact, if you are booting the machine, if you encrypt the boot partition, you will be prompted 2 times. First during the early boot, and after that 1 more time. So basically during the early boot, it will ask you to enter the passphrase, and after the boot process is almost done, it will ask you 1 more time to encrypt the boot partition again. So during that time, if you have somehow access to this process, then you may get the key. But if you only have the hard drive, it should be secure because both partitions are already encrypted. Make sense? Okay.
more questions?
One addition, the unlock key is present in the TPM, and the TPM will only give it out if the system state matches. So if you use secure boot with your keys and only your keys and seal the secret to that state of the machine, it will not release the key to anyone because the system will not allow anyone to boot the system from like a flash drive with Ubuntu. And if you turn off secure boot, the system will not be in the state that it would be expecting the secure boot and like unseal the key, and it will again not like give the key out. There was one moment, one slide where the UEFI binary for group was presented with like, let's add the secret to the UEFI binary. Please not do that, because that would be the place where you could steal the key. If you avoid this place, then it should be secure.
And maybe it's how it works in Windows, because if you use the disk encryption, you don't need to give any password. It's encrypted. If someone steals your computer and left the secure boot enabled, he could try to trick the OS when it boots to get to the data.
You wanna come here?
Yeah, discussion. So
I am standing. I will rather.
No. There are 16 registries, like PCR registers, and you can seal the system state to as many of them as you want. There was like 4 of them on the slide. The 5th is the 7th register, which contains the secure boot state, and you can use more. You can use other ones that contain the partition table layout, the boot loader binary hash, and more. So Windows uses those additional registries with the additional like states, and they pre-compute the state before you reboot. So the key is only released from the TPM for Windows if the other registries match as well.
don't argue with him. He worked with me in Avast, so he should know. So any other question? No. So there was one last mention. It was not question, but it's all on the slide. Pavel, you remove it. So can you please bring it back? No. Just a minute. Yeah, I like it, so I just wanted to read it. This was a note. I just don't understand why Michal is so afraid of it when it's so straightforward. Yeah, no. Is it for Talos? Yeah. I don't know. I think that's all. So one more time, thank you, Emrat. Or you can, take it offline. So, but okay.
Like I understood, you are from Prussia as well, or not?
No.
No. Oh, I see. Because like for this all was for on-prem, and Prussia is running on public cloud.